Through some questions and lots of mistakes in the questions. A 2-year floating rate note issued by a French corporation pays the 3-month MRR of negative 0.55% plus 160 basis points. Notice it's 0.55, not just 0.5, but 0.55. This is 160 basis points. The floater is priced at 101.2 per 100 of par, assuming a 360-day count convention and 90-day periods. The discount margin for the floater is closest to. So we first need a coupon payment here, which is the MRR plus the quoted margin times the face value divided by 4 because it's 3 months. Negative 0.0055, as we have up here, plus the 160 basis point spread times 100 of par divided by 4, 0.2625. Calculate a yield. It's a 2-year quarterly, so our N is 8, future value is 100, PV is negative 101.2, and our payment, which we've just calculated, is 0.2625. We get 0.11174. And of course, that is already in percent form. So to get it in decimal form, you add 2 more zeros. Well, this has to equal the denominator, which is the MRR plus the discount margin. This is what we're trying to solve for. Again, our MRR is negative 0.0055 plus the discount margin. And of course, that's over 4, must equal this. Cross multiply by 4, this turns into this. Add the 0.0055 to both sides, you get 0.9969. None of the answers work. The answer that CFAI gives starts off by saying the discount margin is 195 basis points, and then it ends by saying the discount margin is 50 basis points, which is 1/2 of this, and I'm not sure how they're getting to that, but a lot of their math along the way, or arithmetic along the way, simply just uses wrong numbers. Anyways, there we are, 0.9969. It doesn't exist. Now, it sort of makes sense because what do we have? We have a premium bond. You have the quoted margin of 160 basis points. So you're going to need a discount margin that it's less than 160 basis points. This is 99, but not so much less because it's not that much of a premium, 101.2. That's it. Changes in the required margin, that is your discount margin, that is in the denominator, that is what the market wants. Changes in the required margin for a floater usually come from shifts in the yield curve. No, that would be changes in MRR. Changes in credit risk, exactly. Increases or decreases in inflation. If you have changes in inflation, it will show up in the MRR because that is a nominal rate. So B, a fixed income portfolio manager is looking to value a 1-year US dollar denominated floating rate note that has quarterly payments based on 90-day MRR plus 80 basis points. Assume the following. 90-day MRR, 2.5%. The quoted margin is 80 basis points. Discount margin is 100, and our face value is $100. Without doing any calculation, this floating rate note is priced at. Well, our quoted margin is 80, but the market wants 100. So the quoted margin isn't rich enough, which means we're going to have to get it at a lower price than par, priced at a discount. All right, we have the same question set up, except this time we're asking for the price of the FRN. So we're going to need our numerator and our denominator. Our numerator is our coupon. We have 2.5 plus 80 basis points times the face value, and since it's quarterly, we divide by 4. Each coupon is 0.825. N equals 4. Payment equals 0.825. Future value equals 100. We need our discount. We know that the discount margin is 100 basis points. MRR is 2.5. Divide that by 4, you get 0.875. Enter in these 4 variables, compute PV, negative 99.804. All right, another question where the CFAI has gone way off the rails in the number of mistakes they've made. Bond equivalent yield of a 90-day European bank certificate of deposit quoted at a discount rate of 0.55%. So we have the discount rate for a 360-day year is closest to. We know it's 90 days and 360-day year. Since we have the discount rate, we will first calculate our PV. We have our future value, we have our days over year, and our discount rate. We get a PV of 99.8625. Then to get a bond equivalent yield, we have to use the add-on rate, years over days, and here we're turning it into 365 because we want the bond equivalent yield. This is the add-on rate for a 365-day year. 365 over 90 times future value minus present value over present value, you get 0.5584. The answer that they give you is 0.28 because they divide this by 2. You do not divide it by 2. It is already quoted as a bond equivalent yield. Since they're assuming, well, that's on a semi-annual basis, we'll divide it by 2 to get 0.28. You do not divide by 2. An add-on rate for a 365-day year is the bond equivalent yield. You're done right there. A 91-day UK gilt has face value of 2 million, discount rate of 0.25%, and a price of 1.9 million. If a year has 366 days, the discount rate for the UK gilt is closest to. So we have to calculate it again for 366 days. Year over days, 366 over 91, future value minus present value over future value, because we're calculating the discount rate. You'll get 0.20109, 0.2011. Explain why a money market discount rate, here we're looking at is DR, the discount rate, greater than 0 understates the rate of return to an investor and understates the cost of borrowed funds for the issuer. So we start with the formula for discount rate, and we note that the denominator here is the future value, not present value. For a money market security, if the discount rate is greater than 0, present value will be less than future value. Therefore, the term of future value minus present value over present value will be greater than future value minus present value over future value. So the discount rate associated with this term will be greater than the discount rate associated with this term. So if this term is larger, then the discount rate will be larger by using the PV instead of the FV. So using FV, this discount rate understates the cost of borrowed funds and understates the return to an investor.